This is the 10th video out of 10 for the tutorial that describes setting up the simplest simulation with Lumerical software. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. This part discusses analyzing the results after the simulation has been completed. By the end of previous video, we have already created all the objects and all elements, and we run the simulation. Now let me describe the procedures that we do when the simulation is completed and some results of the simulation need to be analyzed. We click on Monitor in the setting tree. And in this bottom panel, with the result tree, we see all kinds of data. We can select another element in the setting tree. In this case, some other information will pop up in the result tree here. This workspace layout is different from the CST package, where all results appear at once. In contrast, in the Lumerical package, we need to select simulation elements one by one and see results for each of them separately. So we need to know where we are going to look for those results and structural characteristics that we need to analyze. Let's select Monitor. And here in the results section, we select T, which is a normalized transmission in our case. The software provides short notes once you put a cursor next to the line. It is a function of the wavelength or frequency. This is the simulation result that we are looking for. We click Visualize and we launch a new window. It's called Visualizer. There are several places to pay attention to. We still keep the default XY plot here. Next, in the bottom section, we see some characteristics for this line. We need to select absolute value instead of the real part, because we are looking for the total transmission. Now the plot appears flipped in the comparison to the plot of the real value. Then there is an option to export results into the text file. It is here. It is going to be in the text format, and one can use the data in another post-processing software. Alternatively, there is also an option to export results in a PNG file, which would be simply a picture of the plot. Further, there are other basic options for visualizing the results. Now let me go back to the initial plot in the article we were going to reproduce. We can see a good agreement between this transmission shown by the red line in the article and the plot we see in Lumerical FDTD simulations. This transmission has two significant dips, almost down to 0, and then there is another dip up to 0.7 in the amplitude value. In the FDTD simulation, we got a very similar plot. There are two significant dips here and here, and an additional dip up to 0.7. As I mentioned in the first video, in no way we pretend to be comparing the methods or software packages. There is some discrepancy in the results that can be explained by slight differences in the material functions. Besides that, we can further improve FDTD simulation by using a finer mesh. This completes the 10th video and our tutorial on the Lumerical package.